Hello and welcome to another Orange Coast College mathematics video. In this video, we're going to learn how to determine when a given relation represents a function. Now, just to remind ourselves, a relation between two sets A and B is a collection of ordered pairs x and y, where x is in A and y is in B. Now, usually a relation is a collection of ordered pairs, but it can be represented in many different ways. As a literal list of ordered pairs, it can be given as a table, a graph, because a graph is essentially just pointing out ordered pairs in the Cartesian plane, or even an equation. So an equation involving x and y also would represent a relation. Now, a function from A to B is a relation between A and B, so some ordered pairs, where each x is paired with exactly one y. So each x only has one y assigned to it. You can assign different x's to the same y, but every x gets one y only. Example 1. So we wanted to determine if these relations that were given here in A and B are functions. Now, what we're looking for is if x is repeated and the y is different, then that cannot be a function. So here we have 1 is assigned to 3, 2 is assigned to 5, 3 is assigned to 3, and 4 is assigned to 6. So all of these x's are different. So this one is a function. Okay. Now, if we look at B, we look at the x coordinates for each ordered pair, 1, 1, 3, and 5. So here we see here 1 is paired with 2, but 1 is also paired with 4. So this cannot be a function because each x can only have one y assigned to it. So to the number 1, right, both 2 and 4 are assigned to it. So you have 1, 2, and 1, 4 in there. So this one is not a function. Example 2, which of the following graphs represents a function? Now, here we're going to say we're really interested in which of the following graphs gives y as a function of x. Okay, so the idea here is, are there in any of these graphs the same x or one x assigned to more than one y? And the way you could look at that is if you were to draw a vertical line, right, through the graph. If it intersected a vertical line twice or more than once, then that could not be a function, because a vertical line in the Cartesian plane are all of the points that have the same x coordinate. So like if I draw the line x equals 5, that's all the points in the Cartesian plane whose x coordinate is 5. So if a vertical line intersects the graph more than once at any point, so any vertical line intersects more than once, that cannot be a function. So if I look at this one, if I just draw some vertical lines here, it should be clear, no matter where I draw a vertical line, it's only ever going to intersect that graph once. So this one is a function. Okay. Now right away, for the second example here, if I were to draw a vertical line, really almost anywhere through this circle, it's going to intersect in more than one point. So this one cannot be a function. Okay, and for the final one, again, if you draw a vertical line anywhere through the graph given, it's never going to intersect at more than one point. So this one is also a function. Example 3, by examining the mapping diagram, determine if the relations are a function or not a function. So a mapping diagram just has basically an input set, which is like the x coordinates, and an output set, which is the y coordinates. For all of these, we're interested, are any of the inputs, to be a function, each input can be assigned to only one output. So it's not a function if any of the inputs are assigned to more than one output. So if we look at this, right, here P is assigned to M, Q is assigned to N, and R is assigned to N. Now that's fine. Different inputs can be assigned to the same output, but you can't have the other way around. So this one is a function. Okay, for B, each input gets its own output, so that is also a function. And finally, for the last one, you'll notice that Q, the input Q, is assigned to both Y and Z, which that cannot be a function, right? The same one input cannot be assigned to multiple outputs. In our final example, we have two relations that are given as equations, and for each one, we want to determine if y is a function of x. So the idea here is if the input is x, right, the output here is y. If I plug in a value for x, will I get multiple y values? And so for the first one, right, if you just plug in a number for x, you square it, and you add 1, the output, there's only going to be one output because there's only one way to square a number and add 1 to it, right? So if I plug in 5, I get 20. If I plug in 5 for x, I would get 5 squared is 25 plus 1 would be 26. There's no way to get two different y values given a single x. So this one is a function. Now for this one down here, can I plug in an x and get two different y values? Well, if we let x be equal to 10, say, okay, then I would get y squared is x minus 1, which would be 9. And there are two numbers that will give me y squared is 9. Y could be 3, or y could be negative 3, right? If I square either of those two numbers, I would get y squared to be 9. So in other words, plugging in x equals 10 gives us two values for y. So that means one input is assigned to two outputs. So this one is not a function. And that's determining if a relation is a function. So remember, what you're looking for is you're looking for one x that is paired with more than one y. And if you just keep that in mind, this should be no problem. Until next time, have fun.